Welcome back, gents, to section 8 on the octet rule and bonding. Last video we talked about one type of bonding or chemical bonding, which was ionic bonding. This time we're going to talk about covalent bonds. Covalent bonding is described as a sharing of electrons between two or more nonmetals. Now remember, ionic bonding was between a metal and a nonmetal. They had two very different levels of ionization energy, causing one atom to take the electrons from another atom. Here we have covalent bonding, which is the bonding between two nonmetals, in which they share electrons. So nonmetals, as we remember, are located on this part of the periodic table. So nonmetals will bond together in a covalent fashion. Ionic bonding was between a metal and a nonmetal, which have two very different ionization energies, but nonmetals have very similar ionization energies, causing them to share electrons. One isn't that much greater than the other in terms of their energies or how powerful they are. We say powerful. So no one takes from the other. They have to compromise and share. Now, if we think of an example, we have in group 4A, we have 4 valence electrons, meaning they can gain 4 electrons to achieve an octet, or they can lose 4 electrons to achieve an octet. Neither one's an easier path, so they decide to share electrons. An example of that would be carbon. Carbon is one of the most abundant elements on the Earth, and it bonds covalently. So the first thing we do, just like ionic bonding is, we determine how many valence electrons it has. We represent it through an electron dot structure, electron dot diagram. So carbon has 4 valence electrons, and this is hydrogen here, so it's CH4. This is my chemical formula for methane. So I have 1 carbon and 4 hydrogens. And I'll also have 4 hydrogens, 1, 2, 3, 4. Now, all of my hydrogens, as we know, are in group 1A, and they have 1 valence electron. So 1, 2, 3, 4. Now, this bonding is different from ionic bonding in that everything is shared. So each atom is going to share electrons to achieve an octet. Now remember, octet doesn't simply mean 8 always, 8 valence electrons. Carbon is going to share its 4 electrons with other electrons to achieve 8. Hydrogen, however, only wants to get 1 more to be like helium. It only needs 1 more. So if you look on the periodic table, hydrogen is here. If it gains 1 more electron or shares 1 more electron, it will be like helium up here, which has a complete shell of 2 valence electrons. So that's hydrogen's goal is to be like helium. Carbon wants to be like neon. So it's going to try to share 4 more electrons to get 8. Now, I'm going to show you how these bond with something called a Lewis structure. So we're going to draw now what is called the Lewis structure. It's just a diagram showing how these atoms are bonded together. Now, carbon is usually the central atom. So, put carbon in the center. And it has 1, 2, 3, 4 valence electrons. Now, hydrogen has 1 valence electron. If we look, if carbon has 4 valence electrons, it's going to need 4 more to achieve an octet. Hydrogen has 1 valence electron, it's going to need 1 more to achieve the electron configuration of helium. Thus, hydrogen is going to share its 1 valence electron with carbon. So what this means is that carbon has 1, 2, 3, 4 of its original valence electrons, plus the 1 that it shares with hydrogen, this red one here. That's 5. Hydrogen has 1, 2. Hydrogen is sharing this electron here with that carbon. This happens at each site here. So this hydrogen here shares an electron there. The third hydrogen shares an electron here. And the last hydrogen shares an electron here. So essentially, this carbon makes 4 bonds with these hydrogens here. 1, 2, 3, 4. Each bond consists of 2 electrons. 1 from the hydrogen, 1 from the carbon. Now this is one way of drawing it. We usually don't draw them like this in the higher levels. We usually make these pair of electrons into a line. So another way of drawing this would be carbon as your central atom. I'll actually erase this and keep the same color scheme. Carbon as my central atom, and hydrogens surrounding it. Remember, hydrogens, they all have 1 valence electron. My carbons have 4 valence electrons. 1, 2, 3, 4. Now they're going to share. That's the important part here, is knowing that they're going to share their electrons. Meaning, this carbon is going to share its electron with this hydrogen. We represent that sharing by a line, a little dash. That says this carbon has its 4 original valence electrons, and it's also sharing this one, making it 5 valence electrons for carbon. If carbon does this again, and again, and again, carbon now has its 4 original, 1, 2, 3, 4, and it's sharing 4 from the hydrogens. 1, 2, 3, 4, giving it a total of 8, which is my octet. So it has achieved its octet. So each dash is considered 2 electrons. 2, 4, 6, 8. Carbon has achieved an octet. Hydrogen. Hydrogen wants to be like the closest noble gas to it, so it wants to be like helium. So carbon needs 2 electrons total in its outer shell. So hydrogen, needs 2 valence electrons in its outer shell. So hydrogen has 1, 2. This hydrogen has 1, 2. This hydrogen has 1, 2. 1 of its own valence electrons and 1 from the carbon. And this hydrogen has 1, 2. Everything has an octet. Everything is checked off. So these are called Lewis structures. Now, let's do an example. One example is carbon dioxide. Again, we have carbon as our central element. Carbon, if you look at the periodic table, has 4 valence electrons. 1, 2, 3, 4. Oxygen, we have 2 of them. CO2, we have 2 oxygens. One oxygen, we'll put it here. Other oxygen, we'll put it here. Carbon is usually the central atom, so we'll put it in the center. Now, oxygen is in group 6A, so it has 6 valence electrons. 1, 2, 3, 4, 5, 6. Oxygen has 1, 2, 3, 4, 5, 6. They're the same atom, so they're going to have the same number of valence electrons. Now, the objective is to share electrons to achieve an octet. Oxygen has 6 valence electrons, so it wants to share 2 in order to achieve an octet. Carbon has 4 valence electrons, so just like the other example, it wants to share 4 to achieve an octet. So what's going to happen is this carbon is going to share electrons here. And notice, I'm not inventing any new atom. I'm not inventing any new electrons. I'm drawing lines between the electrons that are already there in the valence shells of these atoms. So this carbon shares an electron here and here, here and here. And if we notice, this oxygen now has its original 6, 1, 2, 3, 4, 5, 6 valence electrons, and it's sharing 2 that the carbon is lending it, or sharing with it, 7, 8. So it has 1, 2, 3, 4, 5, 6, 7, 8. So this oxygen has achieved an octet. He is satisfied. This carbon, however, has its original 4, 1, 2, 3, 4, and it's sharing 2 from its oxygen, 5, 6. Carbon only has 6, it's going to need 2 more to share. But luckily it has this oxygen over here to share it with. So it makes another bond here and here. Now this carbon has 2 in this bond, 2 electrons in this bond, 2 electrons here, 2 electrons here, totaling 8 electrons. It achieves an octet. This oxygen here has achieved an octet as well with 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Now if you notice, there are some electrons here that did not bond on both oxygens here. We call these non-bonding electrons, also known as lone pairs. And they're important for their own reasons. They tell us, that this atom has indeed achieved this octet. In higher level chemistry, we usually take them out knowing that they're there. But for our class, we'll keep them there. And these electrons that are in these bonds or making up these bonds are our bonding electrons. Our last example here is H2O, good old water. Now, here we have 2 hydrogens and 1 oxygen. Oxygen is going to be our central atom. It's going to have 1, 2, 3, 4, 5, 6. Hydrogen here, hydrogen there. Hydrogen only has 1 valence electron. This is a pretty easy one in that hydrogen only has 1 choice. It's going to bond here and share an electron to achieve the electron configuration of helium. Hydrogen has 1, 2, it's satisfied. This oxygen is going to bond with this other hydrogen here, giving it 1, 2, hydrogen is satisfied. Oxygen, let's count its electrons up now. It has its original 6, 1, 2, 3, 4, 5, 6, plus the 2 that it's sharing with the hydrogens, 1, 2, totaling 8. So oxygen is satisfied as well. This is covalent bonding using the octet rule. And these are Lewis structures. Know them, study them, take notes on it, gentlemen. Peace.